All right, let's dive into one of the boldest experiments in tech today, Google's Fuchsia OS. This is a brand new operating system, built completely from the ground up. And the key thing to know, it's not Linux. It's a total rethink of how our devices should work, and it could change everything we know about security and stability.
So here's how we're going to break it down. First, we need to understand what's actually wrong with the systems we all use right now. Then we'll get into the radical idea at the heart of Fuchsia, see how it actually works, and tackle the biggest hurdle for any new OS. How do you run the billions of apps that already exist? And finally, we'll ask, what does this mean for the future?
You know, to really get why a company like Google would pour so much money into building a new OS from scratch, we have to look at a single design decision made over 30 years ago. A decision that has created a ticking time bomb inside pretty much every phone, computer, and server on the planet.
Okay, so every OS has a kernel at its core, and there are basically two ways to build one. On the left, you've got what's called a monolithic kernel. This is Linux, this is Windows. Think of it as one giant sprawling program where everything, and I mean everything, your Wi-Fi driver, your graphics, your file system, it all runs together with the highest possible privileges. It's really fast, but man, is it fragile. On the right, you have the microkernel approach, which is what Fuchsia's Zircon kernel uses. Here, the kernel is tiny, absolutely minimalist. Everything else gets pushed out into its own separate, isolated sandbox.
And here's the real kicker. In that big, monolithic system, since everything is sharing the same space, a single buggy audio driver can accidentally scribble over a critical piece of system memory. And when that happens, game over. The entire system comes crashing down. You've seen this a million times. It's the infamous blue screen of death. It's a kernel panic. Your only option is a full reboot.
So how do you solve a problem that's baked into the very foundation of your operating system? Well, Fuchsia's answer is pretty radical. You don't. You just start over. You build something new on a completely different philosophy, one that has been debated for decades to create a system that is fundamentally more stable. And that's where the Zircon kernel comes in.
You know, this whole idea actually goes back to a legendary debate back in 1992 between a computer scientist named Andrew Tannenbaum and a then unknown student named Linus Torvalds. Yep, the guy who created Linux. Tannenbaum basically said that monolithic designs were a dead end, that they were fundamentally broken. Torvalds shot back that sure, microkernels were a nice idea, but they were just too slow to be practical. Well, for the last 30 years, Linus won that argument. Fuchsia is Google's massive bet that Tannenbaum was right all along.
Now, Zircon didn't just appear out of thin air. It's what's called a third-generation microkernel, and it really stands on the shoulders of giants. The first generation back in the 90s, like Mach, kind of proved Tannenbaum's point. They were just too slow. But then came the second generation, like L4, which made a huge breakthrough. They proved the slowness wasn't a problem with the idea, it was a problem with the implementation. Zircon takes all those lessons and aims to be the first microkernel that's fast enough and responsive enough for the devices we use every day.
So how does Zircon pull off this amazing security and stability? The secret isn't what it does, it's what it doesn't do. The whole philosophy is to do as little as possible, but to do those few things absolutely perfectly.
So, while the Linux kernel is juggling hundreds of different complex tasks, the Zircon kernel itself has only 3 jobs. 1, it decides which bit of code gets to use the CPU at any given moment. 2, it manages the computer's physical memory. And 3, it provides a super secure way for all the separate programs to talk to each other. That's it. Everything else, your Wi-Fi, your USB ports, your file system, all of it runs as a normal program with 0 special privileges.
Here's a great way to think about it. A monolithic kernel like Linux is like a giant skyscraper with one central utility shaft for everything: power, water, data. If a single pipe bursts in the basement, the whole building can flood. But a microkernel like Zircon, that's more like a village of self-contained houses. If one house catches fire, it's a tragedy for that house, but the rest of the village is perfectly fine.
And this leads to an incredible practical benefit. Okay, imagine your Wi-Fi driver hits a bug and crashes. On Zircon, that crash is totally contained inside its little sandbox. The rest of the system, your apps, your videos, they don't even blink. A little service called the driver manager sees the crash and poof, it instantly restarts just that one driver. So instead of a full system reboot, you might get a 1-second hiccup in your connection as the system just heals itself.
The security model is also a complete game changer. You know how on old systems there's a root user, or an administrator, a super user that has a skeleton key to do literally anything? Zircon just gets rid of that concept entirely. Instead, it works more like a hotel keycard. An app is given a special key, they call it a handle, that only opens the specific doors it needs to do its job. Your calculator app's keycard simply won't work on the camera's door because why would it ever need to?
Okay, so we've got this super secure, self-healing, incredibly well-designed operating system. It all sounds perfect, right? Well, there's one massive, seemingly impossible problem that has killed nearly every other attempt to build a new OS from scratch.
And it leads to the question you're probably asking right now. If this is so amazing, why aren't we all using it? And the answer comes down to one word: apps. An operating system is nothing without software. And who on earth is going to rewrite the millions of Android and Linux apps just for Fuchsia? It's a classic chicken and egg problem.
And this, right here, is where the real breakthrough happens. This is the piece of the puzzle that makes Fuchsia not just a cool science project, but a genuine contender. It's a project called Starnix.
Starnix is the magic trick that solves the billion app problem. Think of it as a universal translator. It's an incredibly lightweight and efficient layer that lets Fuchsia run existing, unmodified Linux and Android apps. And I want to be clear, this is not a slow, clunky virtual machine. It's a sleek, clever translator that lets Linux apps talk Zircon's language.
Okay, so how does it work? It's pretty slick. Your normal Android app is just running along at full speed. The very instant it tries to do something the Linux way, like write a file to disk, the CPU itself raises a little flag. Zircon instantly catches that flag, pauses the app for a microsecond, and hands the request over to Starnix. Starnix does a quick translation from the Linux request to the native Zircon way of doing things, gets the result, and hands it back. The app just continues running with absolutely no idea that this lightning-fast translation just happened underneath it.
So, with the app problem solved, what does this all mean for the future? Is this the perfect OS? Are there any trade-offs? Let's talk about that.
Let's be real about performance. If you're just measuring raw throughput, like how fast can you shovel data, Zircon is about 5% slower than a super-tuned Linux kernel. But that's not the whole picture. Where Zircon absolutely shines is in latency consistency. It's way, way better at avoiding those little random stutters and hiccups that make an interface feel janky. And for a smooth user experience, that consistency is arguably way more important than raw speed.
Look, Fuchsia is not going to replace Android on your phone tomorrow. That's not the plan. Its first targets are devices where failure is not an option. Think smart home devices that control your locks, and especially automotive systems. A kernel panic is annoying on your phone, it's terrifying in your car's dashboard. Google is also doubling down on safety by rewriting critical parts in the Rust programming language, making it virtually impossible for whole classes of bugs to even exist.
Which leaves us with one big question to chew on. For the past 30 years, the entire tech industry has prioritized speed over security in the very core of our operating systems. With Fuchsia, Google is making a huge bet that in our increasingly connected world, that trade-off is just not acceptable anymore. The question is, are we seeing the beginning of the end for the way we've always built software? It's something to think about. Thanks for tuning in.